Hello, I wanted to go over some coastal landforms and the processes that create them. Basically, we will be talking about deposition and erosion as the main processes that help create coastal landforms. So here we're looking at wave refraction, meaning waves bend around an irregular coastline. So notice we have a headland, or actually more than one. And so the headland is, part of the coastline that's sticking out. So as the waves bend around it, they concentrate their energy on it and erode it. So that's the first process that's happening. It's the headland is being eroded, or gradually being torn apart in a way. That sediment that is picked up from the headland is then deposited on the beaches. So over time, the headlands retreat as they are eroded. Then as the water or waves spread out into the inlets or beaches, they slow down and deposit their sediment, mostly in the form of sand. Okay, so here we have two processes, erosion and deposition. And the combination of the two processes means that over time, as the headlands retreat, as the beaches build up, then eventually we will end up with a straight coastline. We call this process coastal straightening. Here's another process. This one, the net result is going to be deposition, but first let me explain how this occurs. It's called beach drift and longshore currents. So a longshore current is a current that runs parallel to the coast. And as we see here, there are two things going on. One is waves are washing on the beach. Waves usually come in at an angle. But when they come back, when they flush out, they do that at a 90-degree angle, so at a different angle, perpendicular to the beach. So what happens over time is that sediment, again in the form of sand, gets pushed in when the waves come in, and then it gets pulled back in a different direction when the wave goes out. Then another wave comes in and pushes that sediment forward a bit, and then it comes back out. So over time, as you can see, the sand or sediment is moving along the direction of the longshore current. Okay. As the longshore current continues, it will eventually come into an area where there's some open water, and the current slows down and deposits its sediment. So the net result is that a sand spit is formed. So the longshore current here, it's probably coming from this direction, that's the coastline, and over time it deposits its sediment, and over time that spit or extension of sediment continues to grow and becomes ever longer. Here we have an example of a sand spit that has extended all the way across the entrance to a bay. So here's the bay, and this sand spit has extended all the way across as the longshore current built it up with its sediment. And what we have left, this used to be a bay that was open to the ocean. Now it has been closed off, so it becomes a lagoon. So behind the bay mouth bar, which is what this is called now once it closes, we have a lagoon. Lagoons will have both fresh water coming in from streams that are coming down from the hills, and salt water that was the original water that was there. So the combination is brackish, right? We will have brackish water. Here's another depositional feature where instead of the sand spit that was deposited at the entrance of a bay or an inlet, here we have sand that has built up pretty much perpendicular to the coastline. And what it does is that it eventually connects an island. So here we have a small island. It has been connected by a sand bridge as the deposition has grown to reach the island. This feature is called a tombolo. Another depositional feature are barrier islands. These are islands that are long and narrow, and they grow parallel to the coastline. These islands build up, again, by deposition as water or as ocean water deposits sediment when it reaches a shallow area that's near the coastline and deposits some of its sediment. Okay, behind it, we also have a lagoon that forms. Here is Ocean City, which is a city pretty much built on a barrier island. This is in the state of Maryland. This is pretty much a resort town, and you can see the satellite picture and the aerial picture of how that has been developed. Okay, moving on to erosional features. So the features that I just talked about, the landscape, coastal landscape features, were built by deposition of sediment. But waves have energy. Well, moving water has energy, and it also erodes. We saw that when we looked at the headlands in the first slide. So here is a headland that's being eroded, and underneath it we see a hole that has been opened, and that's a sea arch. This is called a sea arch. Here's a picture of one where in this case the whole headland has been disconnected from the mainland. Okay, and when that happens, we get what's called a sea stack. So the erosion is taking place, breaking up the headland. First, we get a sea arch. Actually, first we get a sea cave, then we get an arch, and eventually we get a sea stack. So here is another example of that. Now I want to take you to a few places, show you some additional examples of these features, mostly in California, but also on the East Coast. The first one that I want to show you is this Estero de Limantour. This is in Point Reyes National Seashore, just north of San Francisco. And let me zoom in so we can see that a little better. And what we have here, okay, there we go. We have a sand spit. Okay, so just by looking at the shape of the sand spit and see where it's open here, we know where the longshore current is coming from. So basically, we'll zoom out just a little bit. So basically, the longshore current is flowing this way, and when it came to this open area where the bays are, it began depositing its sediment, and over time, this built up. This spit of sand built up and came all the way across here. Next one, I want to show you what happens when a sand spit pretty much crosses all the way across and a lagoon is formed. So here is Bolina, so just south of where we were, and again we see sand spit here, and we know that the longshore current has to be coming from this direction and then depositing the sediment and creating this sand spit. Technically, this is not a baymouth bar because it's not completely closed. It hasn't quite reached the other side, so it's still a sand spit, but pretty soon it may, unless it's being kept open by people, it would naturally close, and behind it we get a lagoon. I wanted to show you some picture or a picture of what that lagoon looks like from above. So here is the lagoon, and here is the sand spit on its way to becoming a baymouth bar. Okay, the next one I want to show you, so keep going south. The next one is actually an erosional feature close to my hometown in Santa Cruz. So this is Natural Bridges State Beach, and what we have there, I show you, is a sea arch. Okay, it's called Natural Bridges because it had more than one of these. See, they had headlands, and see the headland here has been eroded away, and we were left with a sea arch. It used to have 3, now it only has 1 left, and that will eventually collapse, become a sea stack, and eventually it will completely erode away. So moving on to Mora Rock. Further south, so this is just, between, it's north of Santa Barbara, and so more southern central, I guess, California. And here we have this feature, a tombolo, right? We have the Mora Rock, which is a big piece of rock, but it's connected to the mainland by a bridge. So let me show you a picture of what that looks like from above. So here we see the town of Morro Bay, and the basically sand spit or land bridge that's connecting it and creating a tombolo. And the last place that I want to take you is to another depositional feature, but this one is a barrier island, and barrier islands do not occur on the west coast because in order to have those you need to have a pretty shallow ocean next to the coast, and because of the proximity of plates, we don't really have that here on the west coast because our coast is it's very tectonically active. So let me zoom out here so you can see this is the Padre Island, which is the biggest barrier island in the state of Texas. And as I keep zooming out, you see it more coming to the picture, and you see it's pretty long, very long and parallel to the coast, and it extends quite a ways along the east coast or southeastern coast of Texas. And here is a picture. You can see it's just sand that has been deposited over time, and there's some vegetation growing. They do serve a purpose. They help protect the coastline against storms and hurricanes, so it is important to preserve them. So that's it. Erosion and deposition are 2 important processes that help create our coastal features, and they work. They're always at work.